Welcome to Another Explainer. Today, we're diving into something truly mind-bending, the birth of a black hole. This is, without a doubt, one of the most violent and just utterly fascinating transitions in the entire universe. Most black holes are actually the spectacular remnants of massive stars that have hit the absolute end of the road. Which naturally begs the question, right? How exactly does the universe create its most extreme and violent phenomenon? Think about it. We're talking about an object with a gravitational pull so intense, it literally bends space and time around it. Creating something with that sheer amount of power, well, it requires cosmic violence on a scale that's almost incomprehensible. But if we break it down step by step, we can actually see the mechanics behind the monster. Okay, let's dive into this. We're going to trace this chronological journey through 4 key stages: stellar equilibrium, the iron core, the supernova, and finally the final collapse. Let's look at exactly how a massive star lives, dies, and what happens in its dark afterlife. Stage 1, a star's delicate balance, representing millions of years of harmony. And this brilliantly illustrates what's going on during that time. For millions of years, a massive star maintains a state of hydrostatic equilibrium. It's a literal cosmic tug-of-war. Deep down in the core, nuclear fusion creates immense outward pressure. Meanwhile, the star's massive weight creates a relentless inward crush of gravity. For eons, it's a perfect tie. The outward push exactly equals the inward crush. Stage 2, the iron dead end, a sudden fatal flaw. As that primary hydrogen field depletes, the star essentially panics. To keep fighting gravity, it initiates core nucleosynthesis. It starts desperately fusing heavier and heavier elements, helium, carbon, neon, layering itself almost like a giant burning onion. This desperate fight continues right up until the core creates iron. And iron, my friends, well, that's the beginning of the end. So the crucial point is that fusing iron does not produce energy, it actually consumes it. The moment iron forms, the star's engine abruptly stalls out. That outward pressure vanishes instantly, and gravity, after millions of years, wins the tug-of-war in a fraction of a single second. Stage 3, the supernova shockwave, an explosive climax. When that core collapses, the outer layers just go into free fall. They rush inward at an astonishing 25% the speed of light. Try to wrap your head around that. We're talking about millions of Earth masses of plasma moving fast enough to circle our globe roughly 2 times every second. It's absolutely wild. All of that rushing material violently slams into the newly compressed, ultra-dense iron core. And, with nowhere else to go, it bounces. This massive rebound creates an unimaginable shockwave that rips back through the star, blowing it completely to pieces. This is the supernova. It's an explosion so immensely bright that, for a brief moment, it can outshine all the other billions of stars in its entire galaxy combined. Stage 4, the final crushing collapse. Gravity's ultimate victory. Now, what's really interesting about this is how the fate of what's left behind comes down to a strict cosmic weight limit, known as the Oppenheimer-Volkoff limit. If the core is between roughly 1.4 and 3 times the mass of our Sun, the collapse halts at a hyperdense neutron star. But if it exceeds 3 solar masses, we cross a terrifying threshold. For those cores exceeding 3 solar masses, absolutely nothing in the universe is strong enough to stop the collapse. Not even the fundamental forces holding atoms together. Gravity becomes absolute. It crushes the entire mass of that core down further and further until it reaches a single point of infinite density. Stage 5, inside the black hole, the point of no return. This final collapse leaves behind 2 defining futures. First is the singularity. This is the center point where the entire remaining mass of that giant star is compressed into a region of 0 volume but infinite density. It's literally the place where our known laws of physics just completely break down. Let's move to the second feature and see how this builds. Surrounding that mind-bending singularity is the event horizon. Now, this isn't a physical surface you can actually touch, but rather a strict gravitational boundary line. It is the absolute point of no return. The stakes here are incredibly high. Once anything crosses this boundary, a ship, a planet, or even light itself, the gravitational river flows inward faster than the speed of light. And since nothing can travel faster than light, escape becomes mathematically impossible. Whatever goes in is just gone from our observable universe forever. Stage 6, supermassive black holes, the galactic giants. Now, let's zoom out from dying stars to the absolute monsters sitting at the centers of galaxies, including our own Milky Way. We're not talking 10 times the mass of our sun anymore. These are millions or even billions of times heavier. They achieved this gargantuan size over billions of years through relentless accretion, just greedily consuming ambient gas, dust, and actively merging with other black holes. But this leaves us with a profound mystery. How did these galactic giants really begin? Did they start out as the small stellar mass black holes we just explored and simply eat their way to the top? Or were they formed by direct, massive collapses in the very early universe? The debate is still raging today. Thanks so much for joining me for this explainer. Keep wondering and keep looking up.